Today, we will discuss the design principles of hazardous location equipment and demonstrate how it works. We will then review what needs to be done to ensure the equipment is properly installed and maintained. Enclosures breathe when pressure changes due to fluctuations in temperature and atmospheric pressure. Flammable gases or vapors in the surrounding area can enter the enclosure through the joints, creating an explosive mixture. The design assumes that the explosive mixture of gas or vapor will fill the enclosure. During normal operation, many types of electrical equipment produce arcs or sparks which have enough energy to ignite gas or vapor in a hazardous location. If it is ignited by the electrical equipment, the enclosure is built to withstand the pressure of the explosion without rupturing and without transmitting the explosion to the surrounding atmosphere through its joints. An enclosure is usually made of a cast metal alloy. The thick walls ensure that the enclosure will withstand the force of an internal explosion. The joints are either threaded or machined flat to create a controlled flame path which prevents an explosion of the surrounding atmosphere. The metal surfaces absorb and conduct away some of the heat. There is additional cooling of gases as they mix with the cooler atmosphere outside the enclosure. All hazardous location enclosures are carefully designed to strict standards that include large safety factors. The manufacturing process starts with the pouring of a casting. During machining, particular care is taken to ensure that the joints are flat, smooth, and free from defects. Entries are carefully drilled. And tapped. On flat joints, entries, and threaded joints. Every design is tested to ensure that it can hold pressure and contain an explosion. An explosion-proof window has been installed to allow you to see the explosion inside the enclosure. An explosive gas-air mixture is piped in, and a spark plug is used to ignite it. This is followed by a water pressure test, in which the enclosure is subjected to a pressure of 4 times the maximum explosion pressure. Another test is performed to confirm that the joints will prevent an ignition of the surrounding atmosphere. In this test, the enclosure is surrounded by an explosive gas mixture inside a plastic tent. Note that the internal explosion is not transmitted to the outside explosive mixture. Now, we will deliberately damage the flanged joint to demonstrate what can happen if there is an explosion with a damaged flame path. To protect the machined joints, covers must be handled carefully so that they are not damaged or dropped. Cleaning the joints ensures there will be no dirt in the joint to prevent it from closing properly. A thin layer of grease can be used on a flat joint to protect against corrosion, and on a threaded joint for corrosion protection, and to guard against binding of the threads. Some joints also contain O-ring seals to prevent moisture from entering the enclosures when they are used in outdoor locations. Make sure they are properly seated. If a joint becomes accidentally painted or corroded, clean the joint with a solvent and a clean rag. Never attempt to remove the paint or corrosion by filing or scraping. This could damage the joint. If necessary, the enclosure should be sent out for repair or be replaced. And of course, all bolts must be installed and tightened to maintain strength and flame path integrity. A good precaution is to check all flat joints with a feeler gauge, and threaded covers must be fully engaged. Installation and maintenance instructions are provided with hazardous location equipment. They contain a lot more information than we've been able to cover here. The instruction sheets and labels on equipment are there to help you. Every time you install or maintain a hazardous location device, remember all the care and attention that went into its design and manufacture. Make sure that you are doing your part to keep it safe.